If your e-bike battery connector sparks when you plug it in, the first decision is not which part do I buy. It is, what does that spark tell me about the power path? A spark can point to a connection problem, a charging mismatch, or a protected battery reacting to contact. It does not prove one part is bad yet. It only tells you something in the charging path is not behaving normally. Think of the bike as a chain. The charger feeds the port connects to the battery pack, the battery protection board manages the pack, and the controller and display sit in the wider system. If one link is off, the symptom can show up at the connector even when the real cause is somewhere else. That is why the bike design matters, and why the same spark does not always mean the same fault. Inside the battery, the cells are grouped together, and a protection board watches over them. That changes the diagnosis because the outside connector is only the doorway. If the internal pack state is unsafe or inconsistent, the battery may react before power ever moves the way you expect. So the spark is not just a visible flash. It is a clue that the inside and outside parts of the system may not be meeting cleanly. A charger is not simply pushing power the moment metal touches metal. It needs a clean connection, and it needs the battery side to be ready for that exchange. When that handshake is sloppy, current can jump at the contact point instead of flowing smoothly. That is why a spark can happen even before you know whether the charger, port, or battery is the main problem. The connection has to agree first. Before replacing anything, look closely at the charge port. A dirty pin, a bent contact, moisture, or a loose fit can imitate a dead battery because the connection never settles into a stable path. In the visual, this is the simplest place to check first. If the port cannot make firm contact, the spark may be a symptom of the connection itself, not proof that the whole battery pack is failing. Now bring in the BMS, the battery's protection gate. Its job is to watch for unsafe conditions and stop charging behavior that does not look right. So if the pack refuses normal charging, that does not automatically mean the cells are empty or dead. It may mean the protection system is refusing to open the path. At that point, forcing more tests without a clear reason can be the wrong move. The display and controller can still give useful clues here. If the bike wakes up inconsistently, drops out, or behaves differently when you connect power, that tells you the problem may not be limited to the battery alone. The battery side, controller side, and display side are part of one system. The clue is useful, but it still is not proof by itself. It only shows you where to look next. Here is the difference to watch for. In a normal path, power moves cleanly from charger to port to battery. In a fault, the flow stops, flickers, or splits before it reaches the place you expected. That visual difference matters because it tells you whether the spark is just a brief connection event or part of a deeper break in the system. The shape of the flow is the clue. Start with the outside checks you can do safely. Look for obvious damage, loose fit, corrosion, grime, or signs that the connector never seats straight. You do not need to open risky parts for this first pass. The goal is to confirm whether the problem is visible at the surface before you spend money or time. If the outside connection already looks poor, that changes the whole next step. Now watch the charger light or status result. If the light changes when you connect, that is one piece of evidence. If nothing changes, that is also evidence, but it does not settle the case yet. It can still be the charger, the port, or the battery side path. This is the fork in the road. One observation narrows the list, but it does not give you a perfect answer on its own. Next, think about the battery's seating path on the bike. A rail, latch, or contact alignment issue can create the same symptom as a bad pack because the bike never gets a solid electrical bridge. That is a common mistake. Blaming the battery when the bike side contact is the real weak point. The pack may be fine, but if the mating surface is not right, the connector can still spark. Extra clues can sharpen the diagnosis. Intermittent lights, sudden dropouts, heat, odor, or swelling all change the decision boundary. Those signs matter because they tell you the problem is no longer just a simple plug-in annoyance. If you see them, the next step changes. The viewer should treat those clues as a warning that the system may be beyond a basic connector issue and needs a more careful path. This is where people spend money too early. They buy a battery, a charger, or a controller before they prove which part actually failed. That is the expensive mistake. A spark at the connector can come from more than one place, and the wrong replacement may not change anything. The better move is to use the evidence path first, then buy only when the fault line is clear. Guessing is what burns time and cash. If the battery shows clear damage, heat, swelling, odor, or any sign that makes you uncomfortable, stop there. Do not keep testing as if it were a normal connector issue. That is the safety boundary. At that point, the right next step is not more guesswork at home. It is to step back and treat the pack as a safety concern first, because a damaged battery changes the risk level of every other check. The general power map gets you oriented, but the bike's design decides the next safe branch. Some bikes make the charger path easy to inspect. Others hide the contacts or route the power differently. That is why you cannot force one diagnosis method onto every model. The same spark can mean different things depending on how the bike is built, so the layout has to guide the next check. At this point, use the evidence you already have to choose a path. If the charger result points one way, follow the charger path. If the port looks weak, follow the port path. If the seating or bike side contact looks wrong, follow the battery path. And if the evidence is still mixed, the safest next move is professional verification. The decision should follow the clues, not the other way around. Keep the order in mind. Symptom first, then system path, then safe external checks, then the evidence fork. That sequence matters because it stops you from jumping straight to a replacement part. A spark at the connector is a clue, not a final verdict. When you follow the flow in order, you protect both your time and the bike. That is the simplest way to avoid a bad diagnosis. For the full charging checklist, check the related guide. And if you want a more exact read, comment with your bike model and the exact symptom you see when you plug in. The more specific the setup, the better the next branch can be. The goal is the same. Make the next decision with evidence, not guesses.